Okay, so استاذ زانيمان لسر free body diagram لسر supports لسر internal forces لسر external forces. Okay. Yayna sir Pasha equations of equilibrium hamutan dezanen summation of forces along xy summation of moment. بالنسبة هنا equilibrium of equations we have three equations فكارينين بوحدي برسيا استاح يينا سر example a simple example cantilever beammaker support K at A and you have this triangular shape of load then what is requested over here determine the resultant internal loadings acting on the cross section at C. There lamp pointer, that means you take a section at C. Okay, distance Akeshi from the support 3 meter from the support and from the free end is 6 meter. From this side 6 and from the other side 3. Yakamishet Benispe internal forces. Partially, you've studied engineering mechanics. You have to be able to guess, at least in the beginning, which side is the easiest side to determine the forces. Which side could be the easiest side for you to determine the forces? Admit. What is wrong with it? Sure. Yahya. Okay, Yahya. You've raised your hand, so I expect you that.
Yeah.
Okay.
Well, there is a triangle, so choosing the easier side would be easier to solve the question, which is the right side. Because, yeah, if you cut it from the left side, it would be hard to determine what will the force become. So if
you take the right side of the section, بس نازل مشكلة ما هي بوشينا كم نقدر
فريزبو مامس
ها؟
على مراوس لو نازل فريزبو
لايتوش؟
بله
okay, lemon okay bro. Anyway, so you have two choices. When you solve a problem, the most important thing that you decide on the side you think less calculation could be conducted. Yani outside calculation you can repair. If we cut this section into two, this beam into two, okay, into two halves. One the right side, which is CB, and one on the left side, which is CA, okay? So if you think of it for a moment, you need to spend some time to determine which side is the easiest. It's not, you cannot solve it magically. You say, well, the right side is easier than the left side without thinking. You have to think. If you cut it into two pieces, okay? If you cut it into two pieces, then based on just now Yahya said the right, he said, is the easiest side. Because he thought that, well, if I go to the left side, I need to determine the forces before I get into the internal forces. So he need to calculate, okay, the axial force, the transverse force, the bending moment, because it's a fixed support, okay? This end is fixed. So he has two forces to determine. That's one. The second thing, if he takes the left side, he needs to know what is the force over here. I mean, this is a triangular, so you can't say that this is 270 over here is less. So you need to calculate the force over here in order for you to know the resultant force of this side, so that you could calculate these three forces, amana, these three reactions, in order to calculate them, you have to determine the resultant force that is acting on the beam. And you have a triangular beam, okay? In this case, when you take the section to the left side, it's not a triangular force anymore. It's not a triangular shape, it's a trapezoidal shape. So you need to calculate the force at this edge, okay? You have it already here. Then you can get the resultant of this trapezoidal shape of force, okay? Then you can get the resultant of this trapezoidal shape of force, okay? Then afterwards, you can determine those forces, okay? And then afterwards, you can get the internal forces, okay? So it's not difficult. In fact, it's lengthy. It's lengthy, it takes more time. But the one who thinks that you need to think of it as well. See on this side what kind of problem you have. Do we need to calculate anything prior to the internal forces? If you take a cross section and we eliminate this side, okay? We take it this side. I'll hide the section again, okay? It's pointing to the right side, okay? You're gonna end up with a section. Okay, all what you need is to determine the force at C for the triangular shape. So once you get that, all the forces acting on this side would be the internal forces. So I think this side is easier, as Yahya said. How do we know? You need, first of all, experience play an important role to determine which side is easier, because once you practice, the more you practice, like based on your experience, once you see a cantilever beam with a triangular load, immediately, because you have experience, you have solved many problems of this shape, then you will say, oh, the right side is the easiest side. But for someone who hasn't experienced this example, he has to think, give it like 1-2 minutes of thought, and then think, okay, if I take the left, how many forces do I need to calculate? Oh, I'm gonna end up with a trapezoidal load. Oh, that takes some time for me to know how much is this force. And then I'm going to end up with probably these reactions I need to calculate in order to know about these reactions. So yeah, you need to know about these reactions before you calculate the internal forces. But if I take the left side of the beam, sorry, the right side, I mean, of the beam, all what I need to do is to determine how much of this triangular, how much would it be at this point, this force, and then get the resultant of this, which is easy because they have a triangular shape. And I don't need to calculate any reactions because this side is free of reactions. The B side is free of reactions. So all what I need immediately, I calculate the internal forces, and that would save time. That would save time for you in the exam, okay? Bashbu Yahya, you have given the right answer based on your exam. You have to be you have to think of this. First thing, to decide on the section side, then you start solving the problem so that you could save some time. Çünkü hamu Persiyarakan is not a simply supported beam. Then you might have a frame. You might have a combination of frame and beams, right? You might have a cable, a frame with a beam combined together. So you have to decide on the side where you have least calculations, least reactions, easiest way of calculating resultant forces, because sometimes, like, if you have, like, this is a trapezoidal, would be easy. But if this was like, for example, if this cantilever beam was like having a force that is, what do you call, distributed, and you have like maybe a triangular force, then ends at this point, and then the section, the internal force is required at this point. So of course you take this side, would be much easier than this side because you have a combination of two forces, a rectangular distributed, a uniformly distributed force, okay, in a rectangular shape, and plus a triangular force, okay. So it becomes really complicated to take the left side. The left side becomes really complicated. So basically, the smart one would take this side. The one who gives some time to know which side is easier, I think he would take this side, okay? Then he solve it. Stawa Manzani. So basically, and now it's our free body diagram. We know what is so important about making use of the so-called free body diagram. Can we get the internal forces without having this so-called free body diagram? Can we solve this internal force? No. You have to make use of the so-called free body diagram. So once you take this side or you take the right side, then you're going to end up with a structure that you have cut from its original structure. So you have an element cut from the original structure, and this is treated as a free body diagram. Okay, free body diagram. Okay, free body diagram. Okay, which ones are near? So we move, I think, screen, pointer, raise all. Okay. Annotate. Launch. Okay, so he has taken the right side. Okay, so just apply the equations. Okay, and then you get these forces. Babas, it's easy. This example, nothing's difficult about it. The only thing you determine this force. Do صاحب تاعك دايرة أو force دو زيتو إيش triangular shape أي دو زيتو do صاحب تاع no is equal to this point. At this point, the load, how much is it? It's W over 6 because there over 6. So proportional because of the shape is triangular. So you can determine the load at this point per meter. Okay, the load per meter. Once you determine the load, which is equal to 100 Newton per meter, then you determine the resultant. And all that you need is to determine the axial load, N sub C, definitely no force, then it would be equal to 0. VC, you take the moment, then summation of forces along the y-axis. The only force that you're going to end up with, VC and MC. NC is equal to nothing because we have no axial load. We have no acting axial load. Okay. So you see, no axial load along the y-axis, moment. And forces, engineering mechanics. Based on assumption, assuming okay, left side positive, up to your right side positive, yeah, upward positive, downward positive, clockwise, counterclockwise. Once you get a negative force, in reality, there's no such thing as negative force. So you have to, you have to change the direction of the force. And كبا negative تقدر شو مثلا أما you've assumed that counterclockwise is positive. كبوبا negative كيكيتا positive لدواي يعني واي نسي. أو استا واي نسي طواوا إنجا علي MC M sub C يكسانا ب1008 okay بpositive أي نسي بلام شي لتنيج دعني. The basic assumption was, the conventional one was counterclockwise positive. So you just indicate to it to be clockwise because the negative one is clockwise. Okay, so you then you indicate to its direction so that we know that our assumption was wrong. So this is after correction, we get the right sign convention. The right side of the moment, okay? It's clockwise. Okay? دايم لقلها forcek unit zo مهمة. Unit, you have to write like this. For this V sub C, V is shear transverse force, this one, okay? So it's shear, so indicate to it VC, okay? V sub C, point C. And sub C, okay, normal to this section. This one is parallel to the section within the plane, so it's a shear force. Moment, we know moment, okay. So once you get this, the same thing if, for example, أجر أما VC مثلا ناقص 500 بوايا أتنسي ناقص 500 أوها طواوتك إنجا تنشتي واتك VC دوباره أتنسي أو بpositive V 500 بلام لتنيش 500 لك چي أنسي أما upward positive أو negative 500 لك برا خوار دائني لتنيشتي طبعا لير تنيش. You show the direction of the force. Once you have, once you eliminate the sign, يعني once you get a negative sign, then you leave it and then write it again down next to it, okay, or below it. You write that V sub C is equal to 540 Newton positive, but downward, not upward, downward. Okay, because we don't have negative force. There's no such thing as negative force. Negative indicates that there's something wrong with your assumption. Initially, you didn't know where the force is acting toward. That's why you've got a negative force. Otherwise, there is no negative force. No negative. Okay. The same thing goes to the moment and the axial load. Okay. No negative force. So you يعني أي نسيته negative إن جات تنيشتكي راسك negative كلا أبي شيء ده أنا تنيشت value كا بينصو تشلكي يعني دوسا يعني صدى هرشان يكبيه direction force كا upward to the left to the right okay opposite to your assumption شو كبا negative بدر شو you have to do it is a must you have to do it okay. Of the machine shaft shown in figure below, the shaft is supported by bearings at A and B. So that means the bearing is, does it move to the left or right, which exert vertical forces on the shaft. Vertical forces. Okay. So Dawei could determine the internal forces at point C. So you take a section at C and you have two choices. You either take the left side or you take the right side. It's up to you. So as I said, the easiest, basically, if you can guess the easiest by spending some time and thinking, if you take it this side, how many forces do I need to calculate? And if you take it to this side, how many forces to calculate? Okay. So I think taking the left side is easier. Let us see if he has taken the left or the right. For sure, you have to determine one of the which side he has taken. Wikiwatum, left. So the left side is the easiest. Basically, you guess it. It's easy. You spend some time, see what kind of. For me, Tronzanim is easier. The only force involved, external force involved in this side, is only half of this. Half of is this side anyway. So it takes like 1/4 of the distributed load. Okay. So since the force is uniformly distributed, it's not so critical. If you take the right side, it wouldn't affect the. It's still easy. You can still calculate the resultant easily. Force because it's a uniformly distributed force. It's not a triangular force. Okay, but I looked at this side. I found that I have a force to deal with when I calculate these reactions. Okay. Of course, I'm going to determine these reactions when I take the whole beam as a free body diagram. But when I get the internal forces, if I take this side, beside these support reactions, I need to take this into account in my calculation. So the more force you are dealing with, the more likely you're going to commit mistakes. Okay? And mistake is ziyatira agar force is ziyatira habe. Likelihood mistake is ziyatira. And possibility اگر بونی مستيكي زياتر أبيه أو شوني كفورسي زياتر. بلام أگر تو you took the left side, you see, you just have this uniformly distributed, okay, up to 50 millimeter of the uniformly distributed. You don't have any external force, just you have the support reactions, and you have only one support reaction, which is A sub y. So that would be nice if you calculate the internal forces from this side. You have less headache, you have less forces to deal with, because once you get an additional force, you have to, all the time when you take a moment, you have to think of its location and how far this force is from the location about which you are taking the moment, and you have to know whether it is a clockwise or a counterclockwise moment you're going to end up with this force, okay? Because you cannot assume it. You have to know it. If it is clockwise, then it has to be based on an assumption. It has to be positive, for example. If it is counterclockwise, then it has to be negative. If your assumption is positive, the clockwise is positive, okay? تيجي أوزو مهمة لهين internal forces. That's all. So after you decide on which side, I think the rest is just engineering mechanics, and you determine the reaction. Or Agabena Ser era, he has taken this. First of all, he has determined this side reaction. He doesn't need this side reaction because the section is taken to the left side. So you don't need to waste your time and calculate B sub y. Just A sub y would be enough. And once you get A sub y, then you will have the you take the free body diagram of this, okay? I'm at two-sided. Okay, you're gonna take the free body diagram, okay? And the internal forces, you have an axial, transverse, and moment. This is the resultant of the distributed load. This is the reaction, is acting downward on this beam, is acting downward, okay? Then you calculate what is, you need to know about the axial force. There is no force, so it's 0. You need to calculate the shear force. So you have two forces downward. The shear force assumption is wrong. It's supposed to be upward anyway. And then you need to calculate the moment. You take a moment about this point to eliminate all these forces. You just have this and this, okay? Two forces to deal with. Even when you take a moment, decide on the side, and you can take a moment about this point after determining the axial and the shear. Then you can determine the moment. Even if you take it about point A, you will eliminate one force only. But if you take it about this point, you're going to eliminate only one force only. It's the same. So it's the same. Same. It's not difficult. Same. Either way is easy. You take the moment about A or C. It's the same. Because if you take it about A, you eliminate this force. If you take it about C, you eliminate this force. Okay? So the number of forces you are dealing with is equal on both sides, whether you take it about A or C. Okay, moment about A or C. He has taken it about C. Okay, he has taken it about C. Any question? Okay, my advice to you, when you solve such a problem, solve it in two ways. Take the section on both sides and solve and come up with the same results, okay? To have the experience of solving such problem either way. Sometimes you might decide on the wrong side, so that in the exam, when you decide on the wrong side, and then you have more calculations to do, then you don't regret it because you have enough training on both sides. You can solve it either way, on left or right. But if you decide on the easiest side, it would save time. You would save time, and you could make use of that time. You save time on this question, you make use of it in another question. That's the point, okay? To be fast. يعني engineering mechanics, the strength of material, حتى dynamics أو يختان. The more you save time in solving a question, the more time you're gonna have for another question. So you can save time. Okay, so once you decide, you have to decide on this section, which is at E. So if you decided on this side, you see what kind of forces you need to deal with. And if you decided on the other side, what kind of forces you need to deal with, okay? What else, Chica? Yeah, our بالنسبة Ambro. So if you have any question, you can ask. If not, أبرو هار أوانا أخي لو زيادة بأخرين. بس you decide on GPL.